Well, thank you for the introduction. My name is Colin. I am the Vice President of Corporate Development at Ecotality. We are a publicly traded company, so first off, I provide a safe harbor statement. I'll be providing a little bit of outlooks towards what the EV market looks like in 5 to 10 years that are shared by many analysts. Publicly traded, forward-looking statements. I think everyone knows the drill. So what I'll do is I'll go through a bit of who we are as a company, talk about EV adoptions, talk about the challenges that we face as project manager of the EV project. We're deploying 14,000 chargers across the country, which is no easy task to do by the end of the year. Talk about the grid and grid stability. We recently had ABB take a 20% stake in our company, so we've become very in tune to the impacts that EVs will have on the grid, and it's our stance to make sure that charging a car is part of the solutions for utilities, not part of the problems. And then really talk about what we're doing more in the smart grid effort. So before I do that, I'll just say a couple words about Ecotality. We are publicly traded. We're a leader in clean electric transportation technologies. We've been focused on electric infrastructure since 1989. Our company's grown up through a series of acquisitions. We actually acquired a lot of the battery charging companies and their staff from the utilities when the utilities were being regulated and shedding their non-core assets. So in our technology portfolio, we have some of the original core patents, around 54 patents surrounding DC fast charge. We've been doing charging stations for on-road vehicles for over 20 years. We've also been doing fast charge stations for material handling and airport ground support equipment. We also have a very extensive consulting background. We do all the testing for the DOE's Advanced Vehicle Testing Activity, the AVTA program. So we're kind of like NOAA. We take 2 of every advanced fuel vehicle, bring them to our facility, run them for 160,000 miles, do baseline testing, dynamometer testing, utilizing the proving grounds and local fleets in Phoenix. So we have a very unique blend of car experience, utility background, and also laying out infrastructure. So let's talk a little bit about electric vehicles. Everyone believes that this is a new phenomenon that's coming to market. In reality, there was a big race to see whether it was going to be ICEs or electric to start really the beginning of the century here. The issue is back in the 1900s, battery technology wasn't very good. To have a battery, you need to be really closely located to a transformer, or at that point, it was a power plant. So creating fueling stations for electric cars back then really was not the most cost-effective nor economical way to really go forward. So you had Thomas Edison there really experimenting a lot with the EVs, but in the end it was Standard Oil, it was cheap, which kind of won out. Internal combustion engine was something that had been being used, and they were able to store and transport oil and gasoline at a much easier rate at that point in time than electricity. So that's kind of why electric cars faded out towards the 1950s, 1920s. You had EVs resurge, it kind of ebb and flowed. In the 60s, you saw a couple small-scale EVs kind of hit the market, but really it was the early 90s where you started seeing EVs be explored again. This in part was because we had some oil scares, some other issues that went on, but really there was an economic impetus there to move away from our dependence upon foreign oil. So you'll see the TV Electric, the Chrysler Epic, the GM EV1, the RAV4, these are all kind of the predecessors to today's modern electric vehicle. These were all lead-acid batteries, so they were limited by power factor. And again, pretty primitive technology at the time, but we're seeing the really advancement of lithium-ion batteries, which is really going to help us out. But the biggest issue is that there was no standards around infrastructure. One EV owner could have 3 or 4 different adapter sets to use a public infrastructure. The vehicle inlet on the car was never standardized. So it was nearly impossible to create a universal infrastructure. What's really unique about right now is that we, for the first time in history, have not just 1, but 2 parts standardized amongst every major OEM on a vehicle. Number 1 is the safety belt, and it's taken 100+ years to standardize the safety belt. And number 2 is the charge connector, the actual inlet and charging mechanism that people are using for level 1 and level 2. Every major OEM in North America is using this standard. Addition to that, we have economic, geopolitical factors, environmental factors that are really driving this shift towards cleaner, more efficient, zero-emissions transportation. So we really believe electric vehicles, we've had a lot of head fakes in the past. This time, they're here to stay. We also have standards being developed over DC fast charge, and this, we believe, is going to be a great enabler for electric transportation. This is what we believe will alleviate that main primary range anxiety felt amongst consumers. Right now, every Japanese manufacturer is using what's known as the Chatham standard. This is based off of the Tokyo Electric Power Company standard that they devised and work with Toyota. The Nissan Leaf, the Subaru, the Mitsubishi I.mov, every car that's coming from Asia right now into the United States is using this Chatham standard. In addition, we have people like Tesla and GM, the Society of Automotive Engineers, fighting for a different standard for DC fast charging. So we may see probably two standards emerge for the DC fast charging inlet. But regardless, the key factor is that every OEM is working to create a DC fast charging capable car. That means that, let's say we give out 60 kilowatts, we're putting a kilowatt in there a minute to most of these vehicles. That's tremendous. That means that in 10 minutes, you're getting 10 kilowatts multiplied by 4. You're getting 40 miles in about 10 minutes using DC fast charging. So we think that type of technology makes a lot of sense for specific applications, which I'll talk about a little bit more. But really, EVs are here to stay. We're looking at the marketplace right now, and you're seeing every major global automotive manufacturer announce plans to mass produce and introduce to the market an electric vehicle or a plug-in hybrid electric vehicle. Now, there's a big difference between the demonstration program, which we saw with fuel cells, which the OEMs dabbled their foot in the water, and a mass production market launch. That's what we're seeing today. Nissan, GM, Ford, Mitsubishi, Toyota, these are all household names that are coming out with a full electric car between now and the end of 2012. So in the next 16 months, every OEM is going out with a major car. And you're seeing a lot of new market entrants. Fiskars, Koda, BYD, Think, Tesla. The Think one may be a little iffy depending on their financial situation right now. But you are seeing a lot of entrants come into this space. And the reason why is battery technology is there. You can get a hold of a lot of these battery technologies. The electric motor is something that has been around for a long time. This is a technology that really is applicable to common man. And you're able to see people like Tesla come up and challenge the major OEMs. So we're really seeing a big revolution amongst the EV space right now. I was asked to provide a little bit of an overview in projections. Most projections you'll see go out to 2020. I would rather prefer we kind of keep it a little bit shorter to 2015. I think that's the easiest, most predictable timeline for us to really see what's coming down the pipeline. The OEMs have about a 3 to 4 year life cycle in their planning process, so we're able to see exactly what's coming out there. What we have here is an aggregation of all the major banks and what they predict will be the new market entrants by year. So in 2011, those are mean numbers. The mean number is 48,000 cars, electric cars, will be on the road in the United States or in North America. That raises up to 467,000 cars sold by 2015. If you add these numbers up, the mean numbers get a little bit higher. We're looking around 1.3 or 1.4 million electric cars on the road. So we kind of have to separate a little bit of fact from fiction here. The Obama administration has made a goal that by 2015 we have 1 million EVs on the road. Places like San Francisco in the Bay Area, they're requesting that they have at least 100,000 electric cars in the Bay Area by 2015. That's their domestic, their regional plan. I would kind of have to wait through the fact and fiction, but we would argue, our company would argue that by 2015 we're going to see anywhere from about 750,000 to 1 million cars on the road. I think that's a pretty safe estimate of what we're going to see. This year we should see around 40,000 cars introduced in the North American marketplace by the end of 2011, and that's really going to only ramp up. GM just shut down production for about 2 months to retool the entire Volt plant to make sure that they can build to the anticipated demand that they're seeing in their cars. So we're seeing a lot of volume. And by 2015, we start seeing, let's just say there's 100,000 cars, not just San Francisco, but just say California. That's a pretty mature marketplace for an electric vehicle. By 2020, that's where things start getting a little wonky. Morgan Stanley is probably the most aggressive out there. They believe that 15% of all new cars in the market will be either plug-in hybrid or electric vehicle by 2020. We would argue that number is pretty high. Between 5% to 10% is really where we're seeing most of the major research institutions and banks predict that the market will be for annual new car sales in North America. That is substantial. Right now, North America has about 14 million cars sold a year. By 2020, that's probably going to go up about 20 million. So about 5 to 10%, you're seeing 1 to 2 million cars sold annually in North America that have a plug of some sort. So what do we need to do to support these cars? We have these vehicles coming. It's clear that right now there's a consumer demand and supply is trying to meet that demand. We need to build out the infrastructure. Ecotality is a project manager for what's known as the EV project. This is the largest deployment of charging stations and electric vehicles ever undertaken. We'll be deploying approximately 14,000 charging stations, 18 major cities, 6 major states, to support the first 8,300 Nissan Leaf and Chevy Bolt vehicles. To break that down, it's actually the first 5,700 Nissan Leafs and the first 2,600 Chevy Bolts that are sold into our specific project markets. It is a public and private partnership. This wasn't a pure handout, so we need to spend the money to get it back. So the total project value is around $245 million. Massive, massive undertaking. But this is not a vehicle test. What we're trying to do in the EV project is understand how best to deploy infrastructure to support these cars. We collect data off of our charging stations. What we want to identify is where do people charge, how often they charge, what is their drive habits. Are they going down to 0%, doing a full recharge? Are they going down to 30%? And how do those habits change based on the density of infrastructure in the market? So if you go down to our markets here, places like San Diego, we believe that this is going to be one of the hotbeds for EVs. Obviously the Bay Area is going to be another one, LA is going to be a big one. But in San Diego, we're deploying about 1,000 charging stations, hopefully by the end of the year here. We've already begun some. We've made announcements in Balboa Park. I can allude to a large car sharing program that will also be unveiled this week here in San Diego. They'll be all electric, which is exciting news. But we'll have over 1,000 chargers hopefully set up. We're targeting by the end of 2011. In a place like Seattle, you'll also see another robust infrastructure. But in a place like San Francisco, we're only doing about 20 to 25 DC fast chargers. Dallas, Fort Worth, and Houston, they're only going to see probably about 50 to 60 charging stations that we're deploying. Tennessee, you have about 900 chargers going in the entire state, but those are 4 major cities that are all spread out by about 100 miles. So you'll see more fast chargers going in Tennessee than other places. How people use that infrastructure, whether there's fast chargers around versus a robust level 2 network, those are the questions that we're trying to answer. The government gave us this money because they want to figure out how to deploy infrastructure, where to deploy infrastructure, and what type. When we go to Akron, Ohio, I always pick on Ohio for some reason. When we go to Akron, the DOE doesn't want to spend another $15 million to go to Akron and say, let's deploy infrastructure. They want us to come up with commercially viable ways to create an economically sustainable and scalable business model around charging stations. We can't have what we had in the 90s, where you had free charging, and as a result, you saw chargers go in complete disrepair, no maintenance, no way to find them. We are trying to create a smarter infrastructure that's more focused on the consumer and the consumer experience. It's easily findable, that stays, that washes its own face in reality. And we can't do this alone. We have over 60 different project partners, 14,000 chargers to be deployed, so we are working very closely with Bovis Lend Lease, the largest commercial construction management firm, as well as Jones Lang LaSalle to help us deploy a lot of these chargers. We have a certified contractor network of over 30 different contractors in just those 18 cities. Right now, our utility presence, we have about 25 different utilities that are joining us. So you're seeing us trying to reach out and try to figure out what are the different holes that we have in a massive deployment. What are we going to face with the regulatory commissions, with demand charges, which is a big one. What are we going to see from utilities? How are we going to integrate this in demand response? A lot of questions being raised right now, and luckily for us, we're kind of the guinea pig, so we get to find all the landmines for everyone else. But what we're really doing that's different is we're targeting national accounts.